Okay, as we continue our discussion about the mathematical foundations of this course, the next step in this process is what we call the mole. And no, the mole is not some furry little animal digging holes in your backyard. The mole is a value that we use in chemistry. So let's take a look at exactly what the mole is. The mole is simply a number. The same way if I said 1 dozen is equal to what, you would say 12. 1 mole is simply equal to this value, 6.02 times 10 to the 23rd. So you can see it's a rather large number compared to, say, a dozen. But we need large numbers because we deal with things that are so small. So the mole is equal to exactly 12 grams of carbon-12. And if you remember from the previous podcast, carbon-12 is our standard that we use to determine atomic masses on the periodic table. So it's fitting that the mole is based on that value. So when we talk about a mole of anything, we're saying it's 6.02 times 10 to the 23rd units of whatever we're talking about. So if I said you have a mole of apples, then you have 6.02 times 10 to the 23rd apples. If I said you have a mole of pennies, you have 6.02 times 10 to the 23rd pennies. We call the mole Avogadro's number. And if you remember back when we were talking about the history of chemistry, Avogadro is honored with that value. In other words, it wasn't Avogadro who discovered the mole, it's Avogadro's number in honor of him. Okay, so what we're going to do then is use this value as the basis of our calculations in chemistry. That value, 1 mole, will be used from here until the end of this course. So let's take a look at an example of how we would use that. Calculate the number of iron atoms in 4.48 moles of iron. So what we're going to start doing is using our dimensional analysis techniques that we learned back a few units ago. So what we want to do is start with our number and our unit. So we're going to start with 4.48 moles of iron. And you should absolutely have a periodic table handy from here on out as we're doing this. So if we want to convert from moles to atoms of iron, we're going to set up a conversion factor. Now we want to get rid of moles. In other words, we want to cancel out the unit moles and convert it to atoms. The way we're going to do that is using the relationship 1 mole of anything, and in this case we're talking about 1 mole of iron, that's equal to 6.02 times 10 to the 23rd atoms of iron, because iron is an atom, it's not a molecule. So if we want to get rid of moles, which is in the numerator, remember you could think of that as over 1. So we would want moles in the denominator, what we're converting to in the numerator. So we can say 1 mole of iron is equal to 6.02 times 10 to the 23rd atoms of iron. That way the unit moles cancels, and when we do the math here, 4.48 times 6.02 times 10 to the 23rd, we get 2.7 times 10 to the 24th, and the unit left is atoms of iron. We can apply this concept of the mole to anything. Now, typically what we'll apply it to are atoms and molecules, but let's just say, for instance, you want to know how many moles of apples you have if you have 4.3 times 10 to the 24th apples. So again, start the problem with what you know, 4.3 times 10 to the 23rd apples. Set up your conversion factor. Now we want to get rid of apples and convert to moles. So we're going to put apples in the denominator, and we're going to put moles of apples in the numerator. Remember, 1 mole is 6.02 times 10 to the 23rd apples. When we do the math here, 4.3 times 10 to the 23rd divided by 6.02 times 10 to the 23rd, we get 0.714. Now the units, apples, cancel, so it's 0.714 moles of apples. And again, remember, if we were talking about dozen, 0.7 dozen would be 8.4 apples. 0.7 moles is 4.3 times 10 to the 23rd apples. So all we did was we converted the total number of apples into these groupings that we call moles. You can also go in the other direction. You can say, how many apples do you have if you have 3.4 moles of apples? So we start with our 3.4 moles of apples. Now if we want to convert to just apples, we want moles in the denominator, because that's in the numerator, so we want that to cancel. And we're converting to just apples. 1 mole, 6.02 times 10 to the 23rd apples. Moles cancels. Our unit left is apples, so 3.4 times 6.02 times 10 to the 23rd gives us 2.05 times 10 to the 24th apples. Let's apply this concept now to molecules instead of things like apples. Remember, we started out with atoms, then we talked about how you could apply this concept to anything such as apples. Well, now what we want to do is apply it to molecules. Okay, so let's say we want to know how many moles of CO2 there are in 3.5 times 10 to the 22nd molecules of CO2. So let's start with the given, 3.5 times 10 to the 22nd molecules of CO2. Now we want to convert that to moles. So what we want is molecules in the denominator of CO2, and we're converting that to moles of CO2. So 1 mole contains 6.02 times 10 to the 23rd molecules of CO2. So remember, it's 6.02 times 10 to the 23rd, whatever you're talking about. So CO2 is a molecule, so it's 6.02 times 10 to the 23rd molecules of CO2. The molecules cancel, and when you do the math, 3.5 times 10 to the 22nd divided by 6.02 times 10 to the 23rd, you get 0.058 moles of CO2. And again, you can go in the other direction. Let's assume you have 2.1 moles of CO2, and now you want to convert that to molecules. Set up your conversion. Moles goes in the denominator. We're converting to molecules. So 1 mole is 6.02 times 10 to the 23rd molecules, and it's a good idea to write what you're talking about. So moles cancel. Do the math. 2.1 times 6.02 times 10 to the 23rd gives you 1.26 times 10 to the 24th, and the unit is molecules. Okay, often the question comes up, why do we use this thing, the mole? It's very simple. Atoms and molecules are small. If I sent you to the lab bench and I said, go get 14 grams of carbon, that's easy. You scoop out 14 grams, you put it on a balance. But if you're going to do something with that carbon, in other words, let's say you're going to take carbon and you're going to react it with oxygen and you're going to form carbon monoxide. Well, I'm not going to tell you to go get, let's say, 7.1 times 10 to the 23rd atoms of carbon. That would just be too cumbersome. So what we do is we refer to things in moles. So if we were going to balance this equation, and we'll talk about how we do that later, what we can say now is 2 moles of carbon react with 1 mole of oxygen to form 2 moles of carbon dioxide. So you can say 2 moles react with 1 mole to form 2 moles. So we use this concept of the mole because atoms and molecules are very small. So as we're doing these calculations over the next couple of units, you always want to be thinking in the back of your head that when we talk about a mole, we're talking about Avogadro's number, which is 6.02 times 10 to the 23rd. Oftentimes people ask later in the unit, why don't we use that value anymore, the 6.02 times 10 to the 23rd? It's because we've introduced the concept of the mole. So again, if you have any questions, email them to HannonandChemistry@gmail.com or post your questions on the Moodle site.